Yeah, good evening, children. Good evening, Deepthi.
Good evening, ma'am.
Yeah, I've shared my screen. Visible, right, Deepthi?
Yes, ma'am, it's visible.
Okay. Okay, so the first chapter in your math textbook is rational numbers, or I think integers. Integers, right? But we'll be doing fractions and decimals, and then we'll do integers. So let's take up the definition, or let's understand what is meant by fractions. All right. So a number of the form a by b, where a and b are whole numbers, and the denominator b is not equal to 0, are called fractions. Numbers of the form a by b, where a and b are whole numbers, and the denominator b is not equal to 0, are called fractions. All right. So wherein a is called the numerator and b is called the denominator. A numerator, B denominator. A is any whole number. B also can be any whole number, but not 0. The denominator B can be any whole number, but it should not be 0, because we know division by 0 is not defined. Okay, division by 0 is not defined. So the denominator should not be 0. The numerator can be 0. So numbers of the form A by B, where A and B are whole numbers, but the denominator B not equal to 0, are called fractions. Okay. Now, as I told you, A by B, A is the numerator, B is the denominator. So you can see these examples. 3 by 5, 17 by 6. 8 can be written as 8 by 1. So 8 is a fraction when you represent it as 8 by 1. Okay. Now the different types of fractions. So basically whole number by whole number is a fraction. Whole number by whole number. Whole number divided by a whole number is a fraction. The denominator whole number should not be 0. By the way, what are whole numbers? Natural numbers including 0. Natural numbers including 0. Counting numbers including 0. How do we start counting when there are a few objects lying on table? How do you start counting? 1, 2, 3, 4, 5, and so on. So counting numbers including 0 form the collection of whole numbers, right? Okay. Now let's see the types of fractions. Decimal fraction. A fraction whose denominator is 10, 100, 1,000, 10,000, and so on. Any of this, if the denominator is a 10 or 100 or 1,000 or 10,000, okay, such fractions are called decimal fractions. Decimal fractions have denominator as 10 or 100 or 1,000 or 10,000, or okay, it can be a 10 or 100 or 1,000 or 10,000, and so on. So if the denominator of a fraction is one of these numbers, then the fraction is called a decimal fraction. Vulgar fraction is the opposite. If the denominator is not a 10, 100, 1,000, if it is not a 10, 100,000, and so on, the fraction is called a vulgar fraction. Okay, all right. Then unit fraction. Unit fraction is a fraction whose numerator is 1. Unit fraction is a fraction whose numerator is 1. I'll give you time to read the definitions. We'll just understand first. A fraction whose numerator is 1 is a unit fraction. Proper fraction. We know this, right? So, yeah, in a fraction, if the numerator is smaller than the denominator, the numerator is smaller or less than the denominator, it is a proper fraction. Improper fraction, It's the opposite of this. So if the numerator is greater than the denominator, the numerator is greater than the denominator, then it's an improper fraction. All right, mixed fraction. Say we have 6 2 by 7. Now 6 2 by 7 is nothing. 6 2 by 7 is a mixed fraction. 6 2 by 7 is a mixed fraction. Now 6 2 by 7 is actually 6 plus 2 by 7. 6 2 by 7 is actually 6 plus 2 by 7. So a mixed fraction can be expressed as a sum of a natural number and a proper fraction. Sum because you can see the plus sign here. Okay. A mixed fraction is a fraction which can be expressed as a sum of a natural number and a proper fraction. All right. Okay. So we know 3 1 by 9 is a mixed fraction. So how do you define or how do you explain a mixed fraction? A mixed fraction is one which can be expressed as a sum of a natural number and a proper fraction. This one is the natural number. This is the proper fraction. Put a plus sign in the middle. 3 plus 1 by 9. All right. Equivalent fractions. So say you are given this fraction 3 by 5. You multiply the numerator by 4 and multiply the denominator also by 4. So what is the resultant fraction? 12 by 20. Now we say that 3 by 5 and 12 by 20 are equivalent fractions. Because we originally had this fraction 3 by 5. We multiplied the numerator and the denominator of this fraction by 4. Right? And the new fraction we got was 12 by 20. Now 3 by 5, the original fraction 3 by 5 and 12 by 20 are called equivalent fractions because they look different, but their value is the same. Again, what do we understand by that? 3 by 5 and 12 by 20. We said they look different, but their value is the same. So how do we understand that better? So supposing you have a toffee, a rectangular toffee like this. A toffee is not rectangular, it's cuboidal. I'm just talking to the surface, okay? So now you make 5 parts, 5 portions, 5 equal portions, okay? And you take 3 of it. It is the same as the same toffee, you make 20 portions. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, excuse me, okay, 19. Now there'll be 20 here. Okay, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Same toffee, we have divided, you have to divide it into 20 equal portions. Okay, they don't look equal here. So 20 equal portions. Now, if you take 12 out of these 20 portions, so you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, can you see that the size is almost this one? See, I made a rough sketch, but then you can see it's the same. The portion you get is the same. That's why we say they're equivalent fractions. Can you see? So you dividing a toffee into 5 equal parts and taking 3 parts out of 5 parts is the same as dividing the same toffee into 20 equal parts and taking 12 parts out of it. The size of the chocolate is going to be the same. 3 by 5 and 12 by 20 are equivalent fractions. How did we get 12 by 20? By multiplying the numerator and denominator of 3 by 5 by 4, by the same number 4. You should not multiply by 0. You can multiply by any non-zero number. Non-zero number. You shouldn't multiply by 0. Any non-zero value. All right. So you get a new fraction, right? Now these two are equivalent fractions. This is the explanation. So what is it? In the first one, the toffee is divided into 5 equal portions and you can take 3 pieces, 3 parts of it. In the second case, we have divided the same toffee into 20 equal portions and you can take 12 pieces out of it. the size, the amount of toffee you get is the same in both the cases, which clearly makes us understand that 3 by 5 is the same as 12 by 20. Now, you can also get equivalent fractions like this. Supposing you have a fraction 35 by 50. Okay, so you divide the numerator and the denominator by 5. Okay, you have this fraction 35 by 50. You divide the numerator and denominator of this fraction by 5. So what's the resultant fraction? 35 by 5, 7. 50 by 5, 10. The new fraction is 7 by 10. Again, 35 by 50 and 7 by 10 are equivalent fractions. Same explanation. Toffee, 50 equal portions, you take 35 out of it, is the same as toffee, 10 equal portions, and you take 7 out of it. Okay. So like this, you can get equivalent fractions by multiplying the numerator and denominator by a non-zero number, or by dividing the numerator and denominator by a non-zero number. Equivalent fractions. Okay, so that's what you can see here. A given fraction and the fraction obtained by multiplying or dividing its numerator and denominator by the same non-zero number are called equivalent fractions. Are called because the fraction and the new fraction obtained together, they are called equivalent fractions. One fraction cannot be referred to as an equivalent fraction. Now, this question is incorrect. Now, if I ask you, is 11 by 15 an equivalent fraction? No, it's meaningless. The question is meaningless. Because equivalent fractions is about two fractions or more than two fractions. Two or more fractions. Minimum two fractions. Okay, so a given fraction and the fraction obtained by multiplying or dividing its numerator and denominator by the same non-zero number are because the original fraction and the new fraction you get. These two together are called equivalent fractions. So we understand this. So these are equivalent fractions. Like fractions. Fractions with the same denominator. You have many fractions. They all have the same denominator. Then they are like fractions. You have many fractions with different denominators. Unlike fractions. Irreducible fractions. Irreducible fractions. Now, 23 by 30. Now, the HCF of 23 and 30 is 1. If the HCF of the numerator and the denominator of the given fraction is 1, then the fraction is said to be in the irreducible form. Irreducible meaning you cannot reduce it. Given a fraction, if the HCF of the numerator and the denominator is 1, that means what? The numerator and the denominator, that they don't have anything in common. They don't have anything in common other than 1. So you cannot simplify it. No, you cannot slash it and cancel it by the same number other than 1. If you cancel by 1, you'll get the same fraction. In one table, 1 23 times, 1 30 times, you'll get back 23 by 30. If you try to simplify by 1, if you slash 23, 1 into 23 is 23, slash 30, 1 into 30 is 30. So again, you'll get 23 by 30. So if the HCF of the numerator and the denominator is 1, then the fraction is said to be in the irreducible form. If the HCF of the numerator and denominator is not 1, is something other than 1. It's not 1, something other than 1. Then the fraction is said to be in the reducible form. Reducible form. Like we took 35 by 50. What is the HCF of 35 and 50? 35 and 50. HCF is 5. HCF is 5. So that means what? You can reduce it. It is in the reducible form. It's in the reducible form. You can reduce it. Meaning you can simplify it further using the HCF. So 5 7s are 5 10s are. So 7 by 10. So 35 by 50 was in the reducible form. Now we found the HCF 5 and we simplified it. And now the irreducible form is 7 by 10. The irreducible, meaning now further you cannot reduce it. It's in the simplest form, or we say it is in the lowest terms. It's in the lowest terms. Simplest form, irreducible form, lowest terms, all these mean the same. All right. So let's just see the keywords again. Decimal fraction, vulgar fraction, unit fraction, proper fraction, improper fraction, mixed fraction, equivalent fractions, like fractions. Because one fraction you cannot say is a like fraction. You need to have at least two fractions. Two or more fractions are set, maybe can be called like fractions if they have the same denominator. Unlike fractions, we cannot look at one fraction and say, yeah, that's an unlike fraction. No. Two or more fractions are said to be unlike if they have different denominators. Irreducible fractions, or you can say this irreducible fractions. So this is about one. No, I'm not saying what I've written is wrong. Irreducible fractions are fine. But this is about one fraction. Irreducible fraction is about one fraction. Okay, I'll remove this. Irreducible fraction, one fraction. All right. Decimal fraction means denominator should be 10, 100, 1000, 10,000 or any number like that. Vulgar fraction, denominator is not a 10, not a 100, not a 1000, not a 10,000 and so on. Unit fraction, numerator is 1. Proper fraction, numerator less than the denominator. Improper fraction, numerator more than the denominator. Mixed fraction, a fraction that can be expressed as a sum of a natural number and a proper fraction. Just take an example of a mixed fraction and just visualize it. So just think of something like this. So you can express a mixed fraction can be expressed as sum of a natural number and a proper fraction. Equivalent, I'll not repeat. Like fractions have the same denominator, unlike fractions have different denominators. Irreducible fraction meaning HCF is 1. Not reducible, it cannot be reduced. That means the HCF is 1. Reducible means the HCF is not 1. It can be reduced. HCF is not 1. Very good. Got it, Deepti?
Yes, ma'am. I have also completed the notes you shared before class.
Okay. We have seen addition, subtraction of fractions in 6th standard. For 7th standard, you will be learning multiplication and division of fractions. And you will also have word problems based on these situations. Word problems wherein you'll have to decide if you'll have to multiply the fractions or divide one fraction by the other. All right. Now we're just recalling. Okay, these from. No. I'll tell you when you have to write, I'll tell you. Yeah. So the first one, convert the following to an improper fraction. So how do you do it? 1 3 by 4 is equal to, you need to multiply, right? 1 into 4, 1 into 4 plus 3 divided by 4. 1 into 4, This one you should multiply, then plus 3 divided by 4. So 1 into 4 is 4, 4 plus 3, 7, 7 by 4, correct? Correct? 4, 5 by 7. Multiply 7 into 4 or 4 into 7, both are the same. 7 into 4 or 4 into 7. Plus 5 divided by 7. Not to forget that, divided by 7. So 7 4s are 28 plus 5. 28 plus 5, 33 by 7. All right. So this is how we convert mixed fractions to improper fraction. Whenever you convert a mixed fraction, it will be converted to an improper fraction, not a proper fraction. Mixed fraction, improper fraction, mixed fraction. If you're given an improper fraction, you can divide and put it in the mixed form. If you're given an improper fraction, you can perform the long division and put that or express that as a mixed fraction. If you're given a mixed fraction, you can use this method like what we just did. So you can use this method and put it back to the improper form. Mixed fraction to improper form. So you can switch between improper and mixed. You should do the long division, right? We'll just do the first one. So 7 and 38, right? 7 5s are 35. 3 is a remainder. So the improper fraction 38 by 7 can be written as, use this, like this you should come. 5, this will be the whole number part, this one, 5. And this will be the the proper fraction, 3 by 7. 5, 3 by 7. Use this order like 5, 3 by 7. See, 38, 7. 7 5s are 35, 3 is the remainder. So 38 by 7 is equal to 5, 3 by 7. 5, 3 by 7. Yeah, no, very important. Convert these fractions to like fractions. Do it. Take the heading. You can just give, like question number 1, 2, 3. Use your serial number because I'll be switching. Between different slides, so they'll have different question numbers. So you just you start with one and you continue with your serial number. Okay, don't get confused the number here. You don't have to write example 3. Yeah.
Should I write this?
Yeah.
Yes, ma'am. Should we write the question?
Yeah, always. Finished? Okay, I'm going to work it. Please check if we have the same steps. So the first step is to find the LCM of the denominators. First step is to find the LCM of the denominators. Okay, so 6, 9, 12, right? So in the tables of 2, 2 3s are 9 as it is, 2 6 are. Then you can take 2 again, 3 as it is, 9 as it is, 2 3s are. So now 3, 1, 3, 1. Again 3, 1, 1, 1. So the LCM of 6, 9, and 12 is 2 into 2 into 3 into 3, which is 36. Now, like fractions means all the fractions must have the same denominator. And that common denominator is the LCM. What do we mean by like fractions? All these three fractions must show up the same denominator. Now they have different denominators. The three fractions must show the same denominator. So what is that same denominator? LCM. So first find the LCM. Now we found 36. Now all the three fractions should show this denominator 36. So first 5 by 6. Now you'll have to write its equivalent fraction so that you get denominator 36. 5 by 6, write an equivalent fraction so that the denominator is 36. So for that you'll have to multiply by 6. Correct? Multiply and divide by 6. So 5 by 6 is equal to 5 into 6 by multiplying the numerator and denominator by 6. So you get 30 by 36. Next, 7 by 9 is equal to 7 into 4 by 9 into 4, because the denominator is 9. 9 into 4 is 36. So multiply the denominator by 4 and the numerator also by 4. 28 by 36. 11 by 12. The denominator is 12. So you need to multiply by 3 to get 36. So multiply the numerator also by 3. Okay. So we've converted them to equivalent fractions. So 30 by 36, 28 by 36, not equivalent fractions, sorry, like fractions. I'm sorry. They're not equivalent fractions. These two are 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 equivalent fractions. These three fractions are like fractions. They are not equivalent fractions. They are like fractions. They are like fractions. Because they're showing the same denominator, 36 everywhere. All right. I can wait, please. You have to have all these steps. I'll come later and check your books. I'll give you a minute. Please include the steps which are missing or redo. So the given fractions, they had different denominators, 6, 9, and 12. So the given fractions are unlike fractions. The given fractions are unlike fractions because they have different denominators. But unlike fractions can be converted to like fractions by bringing all the fractions to the same denominator, which is the LCM of the denominators. So first find the LCM and then convert the fractions to like fractions, correct? Now look at this, convert 84 by 98 into irreducible form. It is now in the reducible form. It's now in the reducible form because you can simplify it further. Yeah, for this you should first find the HCF, not LCM. You must first find the HCF. To reduce, not to simplify, you should find the HCF, not LCM. And also for LCM, you need at least two numbers, no? Yeah, that's what you should find. You should find the HCF of the numerator and the denominator. I'll work it for you. I'll work it for you.
Shall we do it?
No, 1 second. I'll just take a different number. Let me take 65 by, not 65. Let me take. 48 by 64. All right. 48 by 64. I'll do for this one and then you can do for 84 by 98. So first find the HCF of 48 and 64. How? For HCF, you must divide both the numbers by the same number. Both the numbers should be divisible by the same number, not like LCM. For LCM, when you're finding the LCM of two or more numbers, you can use any prime number even if one of the numbers is divisible. You have three numbers, no? See, like earlier here, 6, 9, and 12. 9 is not divisible by 2. We started with 2, the prime number 2. 9 is not divisible by 2. But you can use 2 because 6 and 12 are divisible by 2. But you cannot use this procedure for HCF. The same question for 6, 9, and 12, when you're finding the HCF, you cannot start with 2. Because for HCF, you should use a prime number which divides all the three numbers or all the numbers given. Get the difference? No? We have, in this question, we have the number 6, 9, and 12, right? If we have to find the HCF of 6, 9, and 12, HCF of 6, 9, and 12, we cannot start with 2 like we have done here. We cannot start with 2. You have to use a prime number that divides all the three numbers, 6, 9, and 12. So you have to use 3, not 2. But when you're finding LCM, you can use 2 because of the three numbers, 2 numbers are divisible by 6 and 12 are divisible by 2. So you can use 2. 48 and 64. So 2. Okay. 2, 24 and 32. Again 2, 12 and 16. 2, 6 and 8. 2, 3 and 4. Now further, both 3 and 4 are not divisible by the same prime number. 4 is divisible by 2, but 3 is not divisible by 2. So you'll have to stop. Stop. So now the HCF of 48 and 64 is 2 into 2 into 2 into 2, which is 16. So how do you reduce it? 48 by 64. You should divide the numerator and denominator by 16. So 48 by 16 is 3. 64 by 16 is 4. So 3 by 4 is the simplest form or the irreducible form or the lowest form. Simplest form is what is irreducible form. All right. Yeah, you please write on this and then do for 84 by 98.
Ma'am, but instead of finding the HCF, can we cut on the number?
No, use this method. For this question, please use this method. Otherwise, when you solve word problems, you don't have to find the HCF and then reduce it. You can directly do it like as you're saying now. You can divide by 2 and again by 2 and again by 2 and put it in the simplest form.
Yes.
Yeah. When this is given as a question, then follow this procedure. If you have to reduce it, if it's a part of a big answer, then you don't have to use this procedure. You can directly cancel the numerator and the denominator by a common table.
Yes, ma'am. So we have to do 84 by 98, right?
Both 48 by 64 first and then 84 by 98.
Yes, ma'am.
Yeah. Yeah, please check. So 14 how many times? 84? 6 times. And 98, 6 by 7. Yeah. So 14, these two numbers, right? As the answer. Oh. Finished? But as Deepthi was asking us, supposing you have this situation as a part of an answer, you don't have to find the heads. Here the question is to write this fraction in the irreducible form. Then we follow this procedure. But supposing this 84 by 98 is a part of an answer, you don't have to find the HCF. You can straight away take up the numerator and denominator and simplify it using some common table. It can be a prime number or a composite number, anything. So in the tables of 2 how many times? 242 times. And here 249 times. Then 7, 6 times. 7, 7 times. So 6 by 7. So if this one is a part of an answer, You don't have to find HCF and do this procedure. If this is given as a question, like what you had here, convert this one into irreducible form. Then you have to show this procedure. Okay, otherwise you can just slash it like this and finish. Comparing fractions. Okay, so compare, I'll do the first one. Now, multiply like this. What is 3 into 8? 24. What is 5 into 5? 25. Now use the inequality correctly. 24 is less than 25, right? So that means the first fraction is less than the second fraction. That's all. Multiply like this. 3 into 8, 24. 5 into 5, 25. Now insert the inequality. 24 is less than 25. The first number is less than the second number. That means the first fraction is less than the second fraction. That's all. Got it? That's all. Let's do this also together. Tell me. First, write the fractions like this. Then multiply this and write the product here. What is 9 into 24? Write that product here. 9 into 20. You should write 9 into 24 here. And then the product 13 into 16 here. So what is 9 into 24? 200. 216. 9 4 36, 6 3 carried over, 18. Yeah. And 13 16 times. Two not 8. Correct. Now insert the inequality. 216 is greater than 208. That is the first number is greater than the second number. That means the first fraction is greater than, therefore the first fraction is greater than the second fraction. That's all. Step 1 is to write the two fractions given, 9 by 16 and 13 by 24. That's the first step. Then multiply. The order in which you multiply is important. 9 into 24, you should multiply and write it as the first number. Then 16 into 13, you should multiply and write that as the second number. You cannot write anything first. First is 9 into 24, that answer, that product. Then you should write 16 into 13 or 13 into 16, both are the same. Then after finding the products, insert the inequality, less than or greater than sign. So in the second one, you get 216 is greater than 208. That means the first number is greater than the second number, which means the first fraction is greater than the second fraction. Okay? Very easy. No, that's all. We're just recalling of 6th standard. Oh, recalling. I thought you were teaching something like this. Finish this, right? Oh, you didn't, is it? Yes, you should. Yeah. You will get some. Finished, Deepti?
Yes, ma'am.
Okay. So how do you, no, we are not doing this now. How do you arrange fractions? So you must first make them like fractions, correct? Now the fractions given are unlike fractions because they have different denominators. So it's not easy to compare. When they have different denominators, you cannot make out the value of the fractions. So you need to bring them to the same denominator. That is, the fractions are unlike, make them like. The fractions are unlike because the denominators are 5, 10, 14, 35, different denominators they have. They are unlike fractions. Find the LCM of the denominators and make them like fractions. Once you make them like fractions, you can compare the numerators, right? You can compare the numerators. Smaller the numerator, smaller the fraction. Greater the numerator, greater the fraction. When you see the question, when you read the question, you should be able to analyze, get the steps in your mind. So like what we just discussed, the given fractions are unlike fractions. If we have to arrange these fractions in the ascending order, you need to make them like fractions. To make them like fractions, you need to take the help of the LCM of the denominators. So we need to first find the LCM of the denominators. So then using that number, you know that you need to multiply the numerator and the denominator using an appropriate number and bring all the denominators to the same denominator, which is the LCM. Then you will compare them. Now all of them have the same denominator, which is the LCM. All of them have the same denominator, like fractions. Now ignore the denominators. Look at the numerators. Smaller the numerator, smaller the fraction. Greater the numerator, greater the fraction. So arrange it. Can you do it? So what will not, no, what will you first do? LCM. Then each fraction you will write its equivalent. Each fraction you will write its equivalent. That is, you will bring the denominator to the LCM. Whatever is LCM, you will bring each denominator to the LCM. Then they become like fractions, then you'll compare and write. So can you do this? Okay. I'll tell you when you have to do it. Take down the question and leave some space. Yeah. Leave sufficient space. You shouldn't be squeezing in later. Leave sufficient space. How much? No. No. We'll do it here at the end of the class. Okay. So how do you add fractions? Again, LCM. Adding, finding the difference again using the LCM. Yeah. So these questions you'll do by yourself. We'll do. Look at this one. Rohit ate 4/7 part of an apple and his sister Ritu ate the remaining part of it. Who ate more and by how much? Okay, if Rohit had 4/7, how much did Ritu have? 3/7. 3/7. Correct. Okay, Rohit had 4/7. So that means Ritu had 3/7, right? Don't write.
Mom, should we write this down?
No, not now. 1 second. Not now. We'll just understand. I'll tell you when to write. So 1 minus 4 by 7, right? 1 minus 4 by 7. What is 1? Can you write 1 as 7 by 7? Yeah. 1 is 7 by 7, no? 7 by 7 is 1. No, 7 by 7 is nothing but 1. 8 by 8 is 1. 9 by 9 is 1. 10 by 10 is 1. Correct. If the numerator and the denominator, if the numerator is equal to the denominator, then the value is 1. So 1 minus 4 by 7, which is equal to 7 by 7 minus 4 by 7. So that is 7 minus 4 by 7, which is 3 by 7. See, Rohit had 4 by 7, right? So Ritu share might be 1 minus 4 by 7. How do you find what is 1? 7 by 7 minus 4 by 7. So now the denominators are the same. So you can subtract the numerator. 7 minus 4 by 7, which is 3 by 7. Correct? Now, who ate more and by how much? So who ate more? Which is greater? 4 by 7 or 3 by 7? Which is greater?
4 by 7.
Yeah, since 4 by 7 is greater than 3 by 7, Rohit had a greater share, or Rohit ate more. Ate more. By how much? 1 piece. Yeah. No, not, you cannot write 1 piece.
1 by 7.
4 by
1 by 7.
minus 3 by 7 is equal to 1 by 7. So Rohit had 1 by 7 of the apple more. Enough, this is enough. Correct? Okay, 1 by 7, part of the apple. Perfect, yes. All right. Correct. Now I'll share this later because you will miss the order. So we'll do it later. I'll share the image. You got this? What should be added to 15 2 by 3 to get 18 5 by 6? Should subtract. Okay, we'll just take a different example. What should be, or let me. No, we'll just take different numbers for this. Supposing this is 15 and this is 18. Ignore the fraction part, okay? What should be added to 15 to get 18? 3. What should be added to 15 to get 18? 3. How do you get that number 3 using these two numbers 18 and 15? 18 minus 15. How do you get that answer 3 using the numbers here? 18 minus 15. So what did you do? This number 18 minus this number 15. So the answer for this question will be this one minus this one. This one minus this one. Should I repeat? See, if the question is what should be added to 15 to get 18, we all know the answer is 3. 3 should be added. How do you get that number 3 using the numbers given in the question? 18, yeah, you need to subtract. Which one first? Which one should you write first? 18 first and then 15. So the given question is similar to this, right? So in this question, you should write this one first and then this one and subtract. Yeah. To change. We are just talking about the order because it's subtraction, which order to write. Okay. So tell me, we'll do it together. So the required number is equal to 18 5 by 6 minus 15 2 by 3. Correct? Correct? Now convert this.
Yes.
Deepti, you convert the second one to an improper fraction here. You all tell me.
Yes.
Deepti, convert this one to an improper fraction. Have the answer. Yeah, the first one quickly. Yeah, Deepti, you got it. Tell me.
It's 47 by 3.
Correct. One 113 by. Is this right, Deepti?
1 minute, I'm doing. Yes, ma'am.
Now, how do we subtract? We need to bring them to the same denominator. You can add or subtract only like fractions. Remember that. Addition and subtraction can be performed only with like fractions. Now, these two fractions are unlike because they have different denominators. You need to make them like. How? By finding the LCM. What's the LCM of 6 and 3? 6. Okay, so the first one you can write it as it is. This is already 6. So the second one, what should you do? 47 by 3 into 2. Into 2. Correct? You can show into 1 here, children. See, you can show into 1 also here.
The answer is 94 by 6.
Okay, so 113 by 6 minus 94 by 6. Now what's happened? Now they're like fractions. So now subtract the numerators. When they're like fractions, you can subtract the numerators. Continuing here. Subtract the numerators by 6. So 13 and what's the difference? 18. Huh? Is it 18?
It's 19.
19 by 6. Yeah, put this in the mixed form. Correct. That's all. All right. So we'll have to subtract. Then, see, first you'll have to subtract 18, no, 15 2 by 3 from 18 5 by 6. Right? 18 5 by 6 first and then minus 15 2 by 3. Mixed fractions there. So converted to improper fractions. Then they are unlike because they have different denominators. They're unlike. You cannot subtract. To add or subtract, the fractions must be like fractions. They're unlike. So find the LCM and make them like fractions. So we made them like fractions. 113 by 6, 94 by 6. Now they're like fractions. Now you can subtract. How? Subtract the numerators. Write the denominator as it is. Subtract the numerators. So 19 by 6. But this one is an improper fraction. So put it as a mixed fraction. That's all. All right. I'll give you time to write. Not now. Yeah. See, here the question is what should be added? Here, what should be subtracted? We'll take a different question of the same situation, meaning different numbers. And what should be subtracted from 17 to get 11? What should be subtracted from 17 to get 11? What's the answer? I've written the same thing. Situation is the same. What should be subtracted from same situation? I've just used different numbers. What is the answer? 6.
6.
Using 17 and 11. How do you get the number 6? So you should write this number first, then this number, and you should subtract. So in this question, which number should be written first? 17 3 by 4 and then 11 2 by 3. In this order, you should subtract. No, are you following what I'm relating? The answer to this question is 6. 6 should be subtracted. How did we get that number 6? So 17 minus 11 is 6. So we should write this one first minus this one. Same thing here. Okay. So required number is equal to, correct? Okay. So now we'll come from the beginning. I haven't finished this. So you know how to continue. Required number is 17 3 by 4 minus 11 2 by 3. Yeah. Now we'll come from the beginning. Yeah. Do this one. You completed till here. I said you continue with your serial number. Don't write example 6. You please continue with your serial number. Now take the question and work the answer. Very good. Yeah. Oh, yeah. Thank you. Yeah, right. 5 sevens are. Got wrong. Sorry. 5 sevens are. Thank you, Santosh. I'll just clear the screen and do it again. This is wrong. I've taken 2. Yeah, am I right? Please check. Deepti, are we getting the same answer?
Ma'am, I'm writing the final statement.
Use the less than symbol between the fractions.
Yes, ma'am, I got the same answer.
Yeah, next one. Check no, all of you. Satakshi. Yeah. Quickly. Let's see who gives the correct answer first.
Ma'am, I got the answer.
Yeah, good.
25
What's
by
answer?
25 by 30.
No. What's answer? No. No.
Ma'am, I have to make it into improper fraction.
Not
So, reduce to
improper.
lowest.
Correct.
Yeah, okay.
Correct. Okay. Now is 25 by 30 in the reducible form or irreducible form?
Reducible term.
It is in the reducible form. 25 by 30 is in the reducible form. It can be reduced. It's in the reducible form. So after doing the procedure, 5 by 6 is in the irreducible form or the simplest form, or it's in the lowest terms. Yeah, next one. Just write it neatly. One. That's not the. Next. It's an improper fraction, right? Write it as a mixed fraction. You try to reduce it. Like this.
Then what is automatic this? 44.
1. No, you must first try to reduce it. If it is, see, the fraction is an improper fraction. Okay, you have to write it in the mixed form. But before that, see if you can reduce it. You must reduce
How
it.
much to reduce it?
Can you reduce it? If possible, reduce and then put it as a mixed fraction. Is it possible to reduce? Check using the tables of 7. Yeah, quickly. Check using the tables of 7 and tell me if it's possible to reduce.
Yeah. So, 10 times. Why not start by 10? Thank you.
So here we had to find the LCM to add. Then to reduce it, we need to find the HCF to reduce it. The HCF of 119 and 70 is 7. We should first reduce the fraction to its lowest terms. And then 17 by 10 is an improper fraction. Divide and put it in the mixed form. Finished? Done, Deepthi?
Yes, ma'am, but can you just take a screenshot?
Yeah, sure, sure.
Done, ma'am. Should we do all three?
Yeah, all the 3. Yes. Please do by yourself and then check your answer.
Mama, I got the answers for all of them. My first and second answer are right. I don't know for the third one, but I finished it. Yes, ma'am, I got the same answer. Ma'am, you're on mute.
Yeah.
Ma'am,
Am
I
I
got
right?
17 by 6. Yes, ma'am.
Okay. Yeah, others here, Satakshi, Santosh. Working? LCM is correct? Okay. I normally take the prime numbers in the order. It's okay. You can change the order also. That's okay. That's okay. You should get the same value.
Ma'am, for the LCM, I didn't do by 2. I started with 5.
No, I normally do it in the order. Like I try the prime number 2 first and then 3 and then 5. I normally do it in the order. It's okay, but you should have the same primes 2, 2, 3, 5. There should be 2 2s, 1 3 and 1 5.
I got 1 5, 1 3, and 1 4.
No, 4 you should not use. You should use only prime numbers.
I didn't take 4, like 15 and 20. I took 5, so 3 and 4 was the remainder. So I had to multiply those as well.
Oh, you stopped at 3 and 4. You multiplied like that, is it?
Yes, ma'am.
See, to find the LCM, you have to go till 1. That is for HCF. You stop at 3 and 4 when we have to find the HCF of the numbers. For LCM, you'll have to complete with 1 1.
Yes, ma'am. Next time I'll do that.
Finished, the 3 of you? You have the question, right, Satakshi? Yeah, you continue. Yeah, take this question. We'll start with this one.
Ma'am, should we do it?
Yeah. So 5 by 9 into multiply the numerator and denominator by Multiply the numerator and denominator by. No, the LCM is the same, right? 9. Oh, you're doing it in parts, huh? First, you're doing 5 by 9 minus 7 by 12. No. You should do it as a whole. You must work it together. Don't do it in steps like that. Work it as a whole. That's not wrong, but you have to do it like this. You're not wrong. You can do it too, but you will go wrong with the sign.
Mom, I got the answer.
Yeah, what's the answer?
19 by 36.
19 by
36.
36. Okay. Okay, now tell me, you should multiply the, see the LCM is 36. So we need to multiply the numerator and denominator by 4. For the next one, Satakshi. And Santosh for the last one. Last one, Santosh. There's 2 here, right? So multiply the remaining numbers. Just take off this 2, multiply the remaining numbers. We have 2 here in the denominator, right? These are the prime factors. So don't just ignore this 2. Multiply these numbers. 2 3s are 6, 6 3s are 18. So you need to multiply the numerator and denominator by 18. That's what we did for the others also. See, we have a 9 in the denominator here. Look at the board. You have a 9 here, right? So 3 3s are 9. Ignore that. So what are the remaining 2 factors? 2 into 2, 4. So you need to multiply the numerator and denominator by 4. Correct? We have done, I have told you last year when we did. You forgot. So now recall, that's all. See the next one. What's the denominator? 12. 12. So how do you get 12? 3 2s are 6, 6 2s are 12. So what's the remaining prime? 3. So we multiply and divide by 3. Recall now? Yeah. So now you will have to write as 20 minus 21 plus 18. The whole upon 36. What's 20 minus 21? What is 20 minus 21? Minus 1. What's minus 1 plus 18? Minus 1 plus 18. Plus 17 or minus 17? 17 by 36. Satakshi, sorry, the Deepthi, you got 19, huh?
Yes, mom.
Just check if I'm right or you're right. Did you get the same numbers? This one? 20 minus 21 plus 18 by 36?
Yes, mom, I got the same numbers.
Okay, so 20 minus 21 is minus 1.
Oh, mom, I did
Minus-
get 17. 19. I got 17.
Okay, minus 1 plus 18 is 17 by 36.
Yes, mom.
Okay. And 17 by 36 is what kind of a fraction? Proper, improper?
Mom, proper.
Proper fraction. So you leave it like that. If it was improper, then we write it in the mixed form. All right. The remaining answers which we discussed, I'll share this one. Complete this one as homework. This one, I'll share the image. All this till the end of this. So 1, 2, 3, 4, 5 questions. Okay. I'll share the recording. The remaining 5 I'll share as homework on WhatsApp. Please complete it by the next class. All right.
Mom, even example 10 is homework.
Oh, if you finish it, I think we have done that in the class now.
Yes,
you finished it, right?
Yes,
Yeah.
ma'am.